Welcome back to Educator.com, our introduction to C++. We've gone through a lot of fun things, but we haven't, unless you've been doing your homework like you're supposed to, we really haven't seen anything with some real code. So let's do a little bit of real code today. Okay, we're going to put together some of what we've seen into a real working program. It's not a complete program. It's probably not something you can put on the market and sell, but it does everything that it's supposed to do. So what we're going to do is create a simple checkbook program. We'll be storing data in files, so we'll get some file I/O going. We're going to read the file, write the file. We're going to process that data. We're going to be using constants. We will have data types, variables, structures, loops, switch statements, functions, and whatever else I can think up along the way. So we'll learn maybe a couple of new things that we haven't seen before. We'll have a system function for getting the current time. You will find more than one instance. You want to know what time is it now. And we'll have a quick overview of string streams. Okay, let's get started with our checkbook program. We're going to have some structures. Let's bring up some source code here. Okay, here's how we're starting. And we've got our declarations of the various things that we're going to include. And of course, we have our namespace. Now here's our structures. The way I've set this up, we've got three structures. We've got a structure for the user, and his name, address, city, telephone, and a bank code. And as I mentioned before, this is my preferred format because I can define the variable and put a comment there so that when you read this, you know right away, okay, what's name? Name is the name of the user. So you can say like, hello, name. The address, city. Of course, we're doing this for real. You'd have more than one address line because a lot of people have got more than one address line. City, you'd probably have a state, your zip code, your 9-digit zip code, your telephone, your cell phone number, your blah, 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 blah. And just as a quick thing, we have something here where the user can say, I want to use this code for the bank. And we're only going to have one bank account. And so if you're going to have more than one bank account, you'd probably want to design something a little bit differently. And then we have the bank where this account is held. We will be using that as a header to the file. So we'll have a file that has the user information, and we'll have a file that has the transactions in the bank account. The bank itself will be the header, and then the transactions will be all the data after the header. So we have the name of the bank, the address, the city, the user's account number at this bank, a brief description, like say this is my business account, or this is my personal account, checking account, savings account, whatever. We have a count of how many transactions are saved. We need to know what the next ID is going to be, so that we start off with nothing. Our next ID is going to be 0. And then after we create a transaction, the next ID after that will be 1. So this has to be incremented and kept up to date and saved in the file. And our next check number, because obviously checks don't necessarily match the ID. Now this is an important distinction here. Your ID is going to identify the transaction, and every transaction has to have an ID. Every transaction does not have to have a check number. Your check number should not overlap. You shouldn't, 1, 2, 3, 4, 5, and then 3, 4, 5, 6, 7. No, that's not good. You should not have gaps in your check numbers. 1, 2, 3, 4, 5, 9, 10, 11, 12. No, you shouldn't do that either. But it happens all the time. So your ID needs to be unique. Your check number does not. We just have that in the data available. So now here we have our transaction struct. We have the ID that uniquely identifies the transaction. That has to be unique. The date of the transaction, and we want to enforce that the user has a date for each transaction. That's a necessity. The check number does not have to be specified, but obviously a deposit wouldn't have a check number. Sometimes a deposit has a check number. The description, when you're writing a check, is your payor, the payee, paid to the order of. Typically with a checking account, you have the bank's keeping their records, you're keeping your records. You want to say, have we reconciled our data with the bank's data? And of course, people make mistakes. You take a check and you want to void it. So we say, okay, I wrote a check, it hasn't gone to the bank, but I want to erase it, I want to get rid of it. So you void it. In accounting, you don't remove transactions, you reverse them. We don't have anything like that in this, but that's basically the type of things we need to think about. And then, of course, the amount of money that comes in, which is generally always going to be a positive number. In accounting terms, this would be called a debit. And the amount of money going out, which in accounting terms is called a credit. Now, we're going to have to be very careful with accounting terms, because accounting terms can vary based on whether you're in the United States or the United Kingdom. So we will just say amount in. That's very clear, straightforward, unambiguous. The money that comes in goes into that. The amount that goes out, when you write a check, that's the amount that goes out.